Welcome back to our channel. Today, we're going to learn how to balance chemical equations in 5 easy steps. Step 1. Count the atoms on each side of the equation. So let's count the atoms on the reactant side. Sulfur 8, oxygen 2. Then on the product side, sulfur we have 1 and oxygen we have 2. Note that if there is nothing after the element, we assume it to be 1. And that's it. We're done in the first step. So step 2. The big rule for balancing equations is that we can only change the coefficients of those of the numbers in front of the atoms. The number after the atoms, or what we call subscripts, cannot be changed. So let's balance this equation by changing the coefficients. If there is no coefficient written, we assume it to be 1. So right now, there is a 1 in front of these terms. And we can see that there are 2 oxygen in each side of the equation. So the oxygens are fine. But the sulfur atoms on the reactant side, we have 8 and only 1 on the right, the product side. So to fix that, we can change the coefficient and make that an 8. And if we put 8 here, that means 8 times 1 sulfur equals 8. And that makes the sulfur both 8 and equal on each side. But take note that this 8 here needs to be multiplied also on the oxygen. So 2 times 8, we have 16. We've fixed the sulfurs, but the oxygens aren't balanced. So we need to put 8 in here. So 2 times 8, we have 16. And now, we have 8 sulfurs on each side, and 16 oxygens on each side. So this equation is now balanced. Step 3. Don't forget that only the coefficients can be changed. Let's try another problem. So the equation, we have 2 hydrogen, 2 oxygen. Over here we have 2 hydrogen and 1 oxygen. Let's try to put 2 right here. So 2 times 2, that gives us 4 hydrogen. And 2 times 1 oxygen, we have 2. Oxygens are balanced now, but hydrogens are messed up. We can put 2 here at hydrogen, so 2 times 2, that will give us 4. And now the atoms on each equations are the same, so this equation is now balanced. Step 4. Sometimes you have equations that look so scary. But if we have polyatomic ions on both sides, like the SO4 or the NO3, then we can consider that ion to be just one thing. Let's see how that works. So here's the equation. We can see we have 1 calcium here and 1 on the other side. The entire SO4 is one thing, and so we have 1 of those here and 1 on the other side. Na1 and 2 Na on the other side. NO3 is taken as 1, so 1 NO3 and 1 NO3, but it has 2 on the other side, so we multiply it and we have 2. If we put the coefficient 2 here, that will be 1 times 2, so we have 2 NAs, and this applies across, so 1 times 2, that gives us 2. And now we can see that it's all balanced. It isn't that hard, right? Let's try some of the common problems that we have. So we have 1 carbon, 4 hydrogen, and 2 oxygen. Over here we have 1 carbon, and we have 2 oxygen. And then we have 2 hydrogen, but be careful that we have to count this oxygen over here as well. So we have 2 plus 1, that will give us 3. Let's start by balancing the hydrogen. If we put 2, this hydrogen becomes 2 times 2, we have 4. But now we have 2 oxygen plus 2 times 1, that will give us 4 oxygens. But that's good, because if we put 2 here on the other side, so 2 times 2 equals 4, and now everything is balanced. This video gives you the basic steps in balancing chemical equations, so you also need to practice and try harder problems. You can check out our other lessons regarding this topic on our channel. Happy learning!